Page 2, part 5, last part of today. So the first thing you're going to see here is a blank unit circle. Feel free to Google your own copy of the unit circle if you've forgotten. But a couple of things that I want you to remember. Remember, in the unit circle, the radius is always 1, right? So what's interesting is like up here when I was looking for sine, cosine, and tangent, if my hypotenuse is 1, so the radius, or we also call this the hypotenuse. Sine is just y, cosine is just x, and tan is just y, right? So down here, when it asks me for these values, it actually becomes easier when I'm looking at the unit circle because I don't have to worry about that hypotenuse anymore because it's just 1. Another thing I want you to think of is the patterns. So remember, like we've got, like think about sort of your special right triangles, right? We've got 30-degree angles and like 60 degrees sort of goes within this because it's got 30 and 30 make 60, right? But 30-degree angles are your key ones, and you've got 45-degree angles. So I want you to think about the patterns that are in this unit circle. So even though we didn't like fully memorize this for the questions that we saw in Honors Pre-Calc, you will need to know it for AP Calc, and it's really actually pretty simple to memorize, and most of you actually did anyway. So if we're looking at a completed unit circle, I want you to just think about the patterns here for when you need to recall it and memorize it in pre-calc. So if I'm looking here, I've got, actually I'll start, and I'll highlight on this one, that's fine. So I want you to look at the patterns. So it moves in 30, 30, right? So these are 30 degrees. And then I've got another 30 here. And then I have 30, 30, 30, okay? Now we're just gonna look at this first quadrant here because technically from 0, I'm sorry, we're gonna look at the first semicircle, the first 2 quadrants, because from 0 to pi would be like 1/1 would just be pi. So that's really technically 1 complete rotation. If we go all the way around, it would be 2 pi. So we'd have to double everything. So we're just going to look at the semicircle when we're breaking this up. So I want to see how many 30-degree sections are there in this semicircle. 1, 2, 3, 4, 5, 6. 6 pieces. Well, how do I write fractions? Well, over 6. 1 pi over 6. 2 pi over 6, which becomes pi over 3. 3 pi over 6, which becomes pi over 2. 4 pi over 6, which becomes 2 pi over 3, 5 pi over 6, and 6 pi over 6, right? Then I can continue this down. This becomes 7 pi over 6. This becomes 8 pi over 6, which simplifies down here. This becomes 9 pi over 6, which simplifies to 3 over 2. This becomes 10 pi over 6, which simplifies to 5 over 3. This becomes 11 pi over 6, and this becomes 12 pi over 6, which is also the same thing as 2 pi, right? The same thing happens, that's like my like 30, 60 degrees, right? And those special right triangles that I'm thinking about, but we're just looking at 30. I also could do the same thing with 45. So this is 45, this is 45. This is 45, and this is 45. So how many 45-degree angles are there? Well, there's 1, 2, 3, 4, right? And I'm just looking at this first half. So then this first one would be at 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Same thing down here. 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4, right? So really, it's not that hard to memorize if you just remember the patterns. Break it down into 30-degree sections in the semicircle at the top. Remember, it's pi over 6 here, and then the 45 degrees are pi over 4, and then you can complete your unit circle from there. You could also remember your points here. Remember how we got these points? We did our trig values, so remember if it's like looking at your height here, so root 3 over 2 is your x, so that means we went root 3 over 2 up 1 over 2. Remember when we proved all of that using our right triangles? You don't necessarily need to do that, but I would just remember that, you know, root 2 over 2 goes with your 45, 45, 90 triangle because it's the same length. 30, 60, 90 would be root 3 over 2, 1/2, and then they switch here because 30, 60, 90, the sides just switch places. So just remembering that they're positive in the first quadrant, your x is negative here in the second quadrant, both are negative in the third, and then your y is negative in the fourth. So once you remember these points here, it becomes much easier to fill in your positive and your negatives with the rest of the circle, okay? So that's the first part, is just completing the unit circle, which you can use this as a reference. The second part is using the unit circle to find the exact values. So think back up to here, the exact values is that x over y, y over x. Well, tan, I know, is, tan is always going to be y over x, right? So y over x. So I want to go to 5 pi over 4, and I want to find what y over x is. So hopefully if it's in this unit circle section, it will be on the unit circle. You could convert to degrees and then work your way around that way. But let's see if 5 pi over 4 is on the circle. So we know over 4 is going to be a 45-degree angle. So 5 pi over 4 is the same thing as 225 degrees. But I want the exact value. So I want x and y, which is negative root 2 over 2 and negative root 2 over 2. So negative root 2 over 2 and negative root 2 over 2, okay? So now if I set this up as y over x, it's going to be negative root 2 over 2 over negative root 2 over 2. Well, two negatives, that's going to just become positive there. What happens when I have two fractions? What's my rule? I keep change flip. So it's root 2 over 2 times 2 over root 2, and I get 2 root 2 over 2 root 2. Oops. Well, I could rationalize this, but if they're the same thing on top of each other, what's going to happen? I'm just going to end up with 1. So the tangent of 5 pi over 4 is going to be 1. All right. I want you guys to go ahead and try both of these since they're in degrees. You could even, well, actually just use your unit circle there. Find the value of these two, the exact values. Just remember cosine is x over 1, since it's a unit circle. 1 is the hypotenuse, and sine is y over 1. Okay, if you like extra problems, go to page 3. You can look at the very bottom to use the unit circle there.